I'm here to speak about overcoming math anxiety, inclusive methods for supporting students. I started working with students in 2016. Before that, I was a graduate teaching assistant at the University of Denver. And in 2016, looking at the data, what we learned was that 4 out of 5 students start kindergarten unprepared for the kindergarten curriculum. So that's what this chart here is talking about. And this happens completely along income lines. So the lowest 20% are the furthest behind, with only the top 20% income earners having their students enter kindergarten prepared for the kindergarten curriculum. Now, I found this extremely surprising, so I started to ask some questions, and I asked, what does this actually mean? Like, where does kindergarten actually start that 80% of the students actually start behind? And what I learned was that kindergarten's prerequisite is counting to 10. And again, this is really hard to believe. So they start with teaching to counting to 20. It's expected that the students understand the numbers to 10 coming in, and 80% of the students don't know how to do that. So digging deeper, what we found out was that this gap in understanding is caused because most parents think counting to 10 is just saying the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But what kindergarten means by counting to 10 is give me 10 items, and the student's able to slide over 10 items and stop on 10. Anyone that's worked with young students know that this is a completely different skill than the first one. And in fact, in the first one, they could just be saying the numbers. There doesn't have to be any actual understanding behind what's going on there. But this turns out to be really important because preschool math scores predict third grade reading scores better than preschool reading scores. This is also really hard to believe, but what we found out was that when you're switching to 2-digit numbers, that's actually the first instance where students are seeing 2 characters on a piece of paper or wherever you're writing it, and those 2 characters mean something more than just the 1 character by itself. And that's something that we have to teach the students as well, because if you show them 11, they might say 1, 1. But, you know, right after that, if you go to 3-letter words, they make the connection that, oh, okay, when I say the sounds k, at, that means cat. It means something more than just the letters by themselves. But more than that, preschool math scores predicted overall scores in 5th grade. So it wasn't just math affected, and that was extremely surprising as well. And there's 2 reasons for this. First, when you're doing the mathematics in your head, it's kind of like chewing gum and walking at the same time. It's a mental exercise that you're undergoing. And the second reason is because of the innumeracy idea. So someone that says, I'm just not a math person. But if it's okay to not be a math person, it might be okay to not be a reading person or a gym person or whatever. So as we kind of degrade the integrity of the subject, the other subject's integrity degrade as well. This next chart here shows basically, again, by income, the percentile of the student starting at age 6 and going through age 12. And what we see is that there's very little bit of movement going up, and it's just kind of the top tiers that are going up. What that means then is that students that start behind tend to stay behind. And the percentile at which a student enters the education system tends to be the percentile at which they exit the education system. This all results in 75% of high school students that are not proficient in high school mathematics and 69% of STEM majors switching to a major with less mathematics. But when you look at the 2 charts together, what you figure out is that the students that could understand the teacher when they entered kindergarten, they actually improved over time. So the education system in the United States actually works if the student can understand the teacher. So that's the challenge. Can we get all the students in the classroom to understand the teacher? I've got a PhD in math and computer science from the University of Denver in 2008. But before that, I was also a software engineer at many different companies such as Lucent Technology. I've worked on atomic clocks. I've worked at Dish Network on set-top boxes. I've done a lot of different engineering projects from the operating system all the way up to web. And in 2016, we founded Elephant Learning, and since then, we've taught over 180,000 years of mathematics to around 150,000 students. We're not here to sell the software. I'm just doing this because We want to empower children with mathematics. We developed a coaching program so that the students that are coming through our system, they're able to go to a resource that may not be their parents for coaching. And that coaching program is what I'm presenting to you today. First, I want to talk about the origin of the math anxiety so that we can kind of start to empathize with the student. And to start that off, I want to talk to you guys about what a compact Hausdorff space is. Okay, so the reason why we're talking about that is because even I, when I was in graduate school, did not know what a compact Hausdorff space was. And then my professor told me, well, it's a space with a lot of locales. It's kind of like the reals. And I got it. And this is kind of the experience that the students are having in the classroom, except in third grade, because they might not have that number sense, or they might not have that language around the quantities or the numbers or the operations or whatever they might be working on in class. And it's just up to us to get them that language, because ultimately that's what they're learning. But more than that, in mathematics, the ideas build on top of each other. So for example, you can't really understand what multiplication is unless you understand what addition is. And so as these students move along, if they didn't really understand the prior concepts, now they're completely lost. But one of the main issues is this idea of answering wrong. So when you think about being wrong, like there's this extra emotion around it, maybe like a shame, or I don't know, sometimes I feel the wrong and it just feels wrong. It feels wrong to be wrong. And so like ultimately, one of the main things is can we start to disambiguate the idea of incorrect from the idea of being wrong? But finally, for the student, there's really no good strategy if they're avoiding the mathematics, because the materials are foundational for being a functional adult. And the next screen here is me chatting with our internal version of ChatGPT. And I asked ChatGPT this math question, and then I realized that I actually put numbers in there that it was going to figure out. But like 4 red pins and 2 blue pins, each red pin is worth $10 and each blue pin is worth $5. And when you do the math on this, that's $50. So it got it right. But if you ask the same question and you change it to 3 blue pins, it still says $50. So ChatGPT cannot do this simple third grader multiplication question. But human beings still are required to do this. And that's how foundational it is. So ultimately, human beings are meaning-making machines. That's what we're doing. As we're growing up, we're learning the language through inference. So we're watching everyone else speak, and we're trying to figure out what do the words mean in the context from where we are. So we add meaning to all of the experiences and events that we have in our life. But there's this idea that like there's these certain meanings that we could add to events where it's not true or it's not provable. And these are typically statements about ourselves. So like if I'm not answering math questions correctly, and now I'm adding the meaning that I'm stupid, this has nothing to do with the outside world. This is all happening within me. So at the bottom of it is this idea of I can and I can't. So the base belief behind the math anxiety is I can't do it. So whatever it is that we've decided to believe around this, we're going to make it true. The I can't, they engage in self-sabotage. They engage in different behaviors that are going to cause them to not succeed. They might even be ready to say the right answer, and then you'll see them move away from the right answer. They'll second guess themselves. That's because they have to prove to themselves and the world that they can't actually do it. On the other side, you have the I can do it. And in the I can world, there's authentic attempts to answer the question and learn from their mistakes. Ultimately, at the basis of it, that's what we're fighting. What I want to do is I want to introduce this basketball hoop analogy. So this is what we're using with our parents and also internally to help students start to overcome the math anxiety. So basketball and mathematics are alike in that anyone can look and see, did the ball go in the hoop or not? With mathematics, we feel like we can force the ball into the hoop sometimes when we give them a procedure or when we try to give them an answer or in the course of our helping. And if that were to happen in basketball, that would kind of look like somehow the coach is shooting for the player. And if we did that, then at the end of the day, the player wouldn't believe that they could play basketball. They'd believe that the coach can play basketball because the coach is the person putting the basketball into the hoop. And so one of the first things is to start to move to a scenario where we're trying to empower the students to go ahead and try to take the shot, even though the ball might not go into the hoop. And the reason why is because as they're taking that shot, they're going to start to think about the problem that they're working on. And as they're thinking about it, now there's opportunity for us to come in and provide them with information like a hint or a definition or some sort of a basis for them to begin to understand, how do I come up with the answer on my own? And what that does is it builds problem-solving skills. In mathematics, when the ball doesn't go in the hoop, there's always an opportunity for learning because it always means that there's some sort of underlying concept that might not be understood completely. And so that gives us an opportunity to provide definition or provide clarification to the student. I'm going to show you how to do that in a moment. How is basketball and mathematics alike? Well, when the ball doesn't go in the hoop, the only option is to shoot again. We have to accept the ball didn't go in the hoop, and now we're going to try again. And the same thing's true in mathematics. We have to try again. Finally, successful coaches are committed to their players' success. So when we commit to the students succeeding, that's when we're going to start seeing them be more successful. Now we're going to move into the strategies. And a lot of these are built off of the basketball analogy, so I'm just going to kind of randomly switch between basketball and math. So the most important thing that we can do is we can start to meet the student at their level. So that's kind of what our system was designed to do. We start with the placement exam. We find out where is their level of understanding, and then we start addressing it there. But many times when we're doing it in the classroom or when we're working with the student one-on-one, there's a very specific misunderstanding that we're working with because they're working on a very particular problem. And so what I'm going to teach you now is called the why method. And I think it's fairly well known, but it's worthwhile talking about just so that we have it in our tool belt. And the way it works is like this. You go ahead and let the student answer the question incorrectly, and then you ask them, why do you think that's the correct answer? And when they start to explain to you why they think that's the correct answer, you're going to be able to determine what it is they don't understand and either offer a clarification or a hint. So now I'm going to give you an example. So in our system, we have a problem where there's 2 columns worth of objects. And it asks which column has more objects than the other column. And the answers are left or right. So they'll say the right one has more. And then it'll ask, how many more does it have? So we had a parent call in and she says, well, when I ask him, I let him answer incorrectly. He says 13 because there was 13 in the column that had more. So in this case, what the student's not understanding is that the idea of how many more is really referring to the difference. And so by clarifying that language now for the students, when it's asking how many more, we're really talking about this idea of the difference and then explaining what the difference is and maybe even visually doing it. So in our system, you can start to highlight the number in the left column into the right column. And then you can say, see, the ones that are not highlighted are the difference. So it gives a nice visual ability to do it. But wherever you're working with the student, however you can do it, you're going to be able to explain what that idea is to them. The other option is to give them a hint once you figured out the why. So for example, we might have a problem in our system where there's an area and we've broken into 2 columns, 2 full columns, and then the last column has 4 blocks in it. And so in this example, maybe the student's having a hard time figuring out that they're trying to find a common denominator. In this case, I think it was 1/30. And so the hint that we gave to the student was, imagine the lines going all the way across. so that they could then imagine that now there's 30 pieces here instead of just the 2 big columns and the 4 in the last column, or whatever the exact problem was. But ultimately, every now and then you might be speaking with the student and you might figure out that they're not really at the level that they're at. So a good example of this is I was working with a student who was looking at a number line problem, and on the right side of the number line was 1/4. And there was a line in the middle. So this is really a question of like a fraction of a fraction. And when they answered a half. And I said, well, why did you answer 1/2? And the student said, well, because the line is in the middle. And so I said, okay, well, what if we kind of imagine zooming out? So now here I'm thinking about the concept, which is, okay, so we're really splitting something in half, but that thing that we're splitting is not a whole. And so I got to show them the whole. So what if we zoom out and we draw this line from 0 to 1? And the student wrote 1/4, 1/5, 1/6 for where 1/2 would be, and then 3/4. And so like, okay, so this student's actually having a problem, maybe with fractions in general. But they were answering a fractions question correctly. So now, after that, I'm kind of working backwards with them, back to where I know they understand, to try to figure out where did we lose them? And then we can start filling in those gaps from that level. And so what we do in our system is we do this define, recognize, produce type of methodology. And this is how it works. So in mathematics, we have this idea of definition. We're just going to tell you what it is. So like 7 times 3 means 7 plus 7 plus 7, 3 times. So that's the definition. And whenever we give the student a very concrete definition, you're going to find that their anxiety goes away very quickly, and they're going to be able to speak with you about this thing because you've made it very precise for them. The recognize is, can they recognize the idea at play? And I'm going to give you guys an example of this just now. So I like to go back to the numbers because it's the easiest place to talk about this kind of stuff. But the define would be, I have one thing, click on one, and I'm showing one object. So we're kind of connecting the idea of one. The recognize would be, how many fingers am I holding up? Or how many things do I have on the screen? Or etc. The last step is the produce. And that's when they're using the idea to solve the problem. So that's like, give me 10 things. Or they're using multiplication to solve the problem. So they're looking at the problem. They know, I got to multiply 7 times 3 to get the answer. And so when you're kind of working with them, then what you want to do is the why method. Try to figure out what they don't understand. Give them the definitions, and then see, can they recognize the idea at play? And then finally, can they produce, and that can they answer the question that they originally were set out to solve? So that's the first strategy. And that's mainly just to meet them at their level of understanding, because at the end of the day, the anxiety is coming from the idea that they don't really understand what's happening. And so if we're able to clarify that for them and then meet them at their level while we're clarifying it for them, that anxiety goes away. The second thing, and I think this is the most important thing because I've worked with so many different parents and I can hear them communicating that they don't believe that their student can do it. And that's really kind of like sad, but at the same time, it's one of the most important things. And that's why I wrote in the beginning, like, if you're committed to the student's success, then the student's going to be successful. We tell our coaches to say to the parent, I believe your student can do it. If we're on the phone with the student, we tell the student directly, I believe you can do it. And this is the advice that obviously we have to then get back out to the educators, because if the educator is saying to the student, I believe you can do it, you're counteracting that I can't believe. And what's happening is that, like, cognitively, the student's not going to want to let you down because they don't have maybe a lot of people in their lives that's communicating to them that they believe that they can do it. One of my coaches came back to me and said, I was on a phone call with one of the students this week, and I told the student, I believe you can do this. And she started crying. And she said, you're the only person that believes I can do this. That's a lonely world to live in. So it's important that we're saying it out loud, and it's important that we're communicating it to them because, again, we're kind of flying in the face of that I can't do this belief, And to some degree, like, they're going to try because they don't want to let you down. And they're going to try to show you that they can do it. But the next thing is to mirror the evidence of performance to the student. So if I'm looking at the data and the data is showing me that the student can't answer this question, then it's definitely not a good idea to tell the student, well, I believe you can do this, right? So before the coach says to the student, I believe you can do this, they'll go to the history screen, they'll look, they'll say, yeah, no, I have evidence. Look at this other question that you answered. It's just like this one, right? And now we can mirror that evidence back to the student that they can do it. In our system, the first thing that you see when you log in is your elephant age. So that's your math age, if you will. It's like the Wii Fitness age, but for math. And we have a graph of where they started and where they are now. And so that's another thing that we mirror back to the student. We say, look at all the progress that you've made. This is just not normal. Look at these graphs. For the general public, you don't see any movement up, but you've learned over a year of math in the last 3 months. And so this is proof that you can do it. Anything that we can do to mirror back to them that they're having success, that also helps. This goes back to then, like, why are we looking at the evidence? Well, because I want to be able to set achievable goals for them. And I mean, I think the best example of this is my trainer in the gym. So like, he gives me weights, but he's told me, before I give you the weight, you have to trust that you can pick up the weight that I'm giving you. And so that's ultimately what the student is doing with us in the classroom. They're trusting that they can solve whatever problem it is that we're giving them. And so when we give them the problem, we also kind of have to make sure that it is something that they can solve. But even from there, what we want to do is we want to set achievable goals a couple of months out, right? And for our system, it's pretty easy, but you're going to figure out how to do this in the classroom pretty easily as well. We just say, where would you like to be a month from now, or 2 months from now, or 3 months from now? What we want to do is we want to get a commitment from the student on what they believe is achievable. And then we want to give them a plan that's based on effort that they're putting in. So it's not based on necessarily achievement, but more based on effort. For our system, it's easy. It's, well, are you going to put in 30 minutes this week? Or do you want to put in 50 minutes this week, right? Because if they put in a little bit more time, they'll get a little bit more progress. But we set achievable goals, and then we come up with a plan to utilize effort to achieve those goals. Well, okay, so let's go into some more coaching strategies. Okay, so this one is to maintain the hoop. And when I'm talking about maintaining the hoop, I'm talking about we can't compromise on whether things are right or correct or incorrect. I think that's a better way to say it. And I don't know why, but like, this is the scenario, at least at my child's school. We sent him in there in its first grade, and apparently they don't grade homework. So there is no hoop. Yeah. And so then the teacher tells me that, well, yeah, I mean, he doesn't really concentrate to answer the questions. And I go, yeah, I was really hoping that you'd be the person marking it correct or incorrect so that he would have motivation to focus. And so now we were left to do that at home. And so, but this is a really important thing, right? Because it's not a basketball hoop if the ball doesn't go in or out, right? So like, if you're just, go answer these questions, and then there's no feedback about whether or not the student answered correctly or not, there is no hoop. It's not there. So this is also when I talk about empathy versus sympathy. So if you look up empathy in the dictionary, what it says is that you're able to understand the emotions of another human being. If you look up sympathy in the dictionary, it means that you have feelings of pity for the other human being. Now, a sympathetic coach is not going to be a good coach, because at this point, now they are also emotional, they're feeling pity, and they're going to compromise the hoop probably. But it is possible to empathize with the student. You can understand how the student feels without having an emotion around it, and then work with it from there. And so then some of these other strategies kind of come into play once you're empathizing. So if a student is exhibiting frustration over answering incorrectly, one of the tricks that you can use is to start to disambiguate the idea of wrong and incorrect. So I alluded to this earlier, but what I would do is I would literally pull the dictionary, the definition out of the dictionary, and this is what it says. So this is from Google. I just screenshot it and put it here. And it says, not in accordance with what is morally right or good. That's the first definition. The second definition is what they actually mean, but the first definition is what they're feeling. They feel morally wrong because they answered a math problem incorrect. And that's not going to work, right? If every time I shot the ball at the basketball hoop, it didn't go in, I felt like I was going to go to hell, I'm not going to play basketball. That's it. It's over. So what you want to do is you want to point this out, right? You answered incorrectly. It's not morally wrong. It might be factually wrong, but let's say incorrect instead. And then that way, there's two different ideas that we're playing with. Another thing that you can do when a student's emotional is you can start to redirect efforts to the next shot. So they might come in, they're starting to get frustrated, but you're like, hey, let's just shoot again. Let's try again. Let's try a different problem. Let's change the numbers. Let's just focus on the next shot. There's this movie on Netflix with Adam Sandler where he's a basketball coach. And in the movie, over and over and over again, he says, next shot, next shot. For the coach, it's the next shot. And that's what it is. We got to keep the players kind of focused on, it doesn't matter if the ball went in or not this time. Let's shoot again. Let's see what happens. Okay, so now what happens if the student's having a meltdown? Well, if I had a player on the basketball court that's just flipping out and starting to throw the ball wildly, I'm going to say, you know what? Let's just take a break because this is not being productive. Let's stop. Let's pause. Maybe I would provide encouragement. Hey, I think you can do this. Anything that you would do in a normal situation when you're working with a player in a sport and they're starting to exhibit a lot of emotion over whatever, it's a similar thing that you can do in the classroom with mathematics or in the after school with mathematics. Finally, it's pretty common if you're going to stick with the student that they're going to start to exhibit their negative self-talk, those false beliefs that I was talking about earlier. And so when they start to do that, you're the person who needs to counteract it. It always starts with, I believe you can do it. And then after that, I try to say something as true as possible. So one time I was on the phone with the student who was having problems with fractions. And she just said, I can't do it. And she started crying. And this is what I said to her. I said, listen, first of all, I believe you can do this. But second of all, you don't know how many thousands of years human beings have been working with fractions. And after thousands and thousands of years, billions of human beings, I don't believe you're the one human being that can't get it. So I believe you can do it. When you're telling them something that's just so true that they can't argue with it, they're probably going to become more emotional, but they're going to go work on it outside of you. They might go home and cry. But hopefully once they're done, they're over it and they come back and they believe they can do it. And that's what we're hoping for. All right, so these are the last set of coaching strategies. The first idea is narrator voice. And that's when you're basically kind of saying out loud what's happening. So if the student starts throwing a tantrum or they start melting down or etc., just saying out loud, so you didn't answer correctly and now you're going to throw a tantrum. What you're doing is you're bringing to their attention kind of what their behavior is, and that also then causes them to start to self-regulate. If in this time when they're having strong emotions around mathematics, if we can get them to say what that emotion is out loud, that starts to deactivate it. Because I don't know why this happens, but they've done MRI studies where if you're able to say the word for the emotion that the other person's feeling, then that deactivates it in them, and then that brings them back to the discussion. But it's more powerful if they're able to do it. So if any of you see a therapist, they're going to ask you, well, what are you feeling? And they really want you to say the word, and that's why. The third is to mirror what the student's saying. So if the student's saying to you, well, I can't do this, you say, okay, I hear you're saying that you can't do this. Now again, they're hearing their words come back to them, and you're saying it that you said it. They don't like that very much. In fact, when you do this to most human beings that are emotional, they don't like that very much. And pretty much what they do is they stop talking with you and they go feel their emotions, or maybe they go for a walk, or whatever they got to do. The last two are really important because at the end of the day, you got to be able to own your thoughts, your energies, your actions, why you're there. And so really that's what it is you have to own your energies, your thoughts, your actions. I'm here to help you. I'm here to coach you to success, etc. And while you're doing that, you can't own any of their thoughts, energies, or actions. So sometimes when someone's emotional, they're going to try to push the blame back out onto you. And this typically sounds like an accusation. You're trying to do this, or you're trying to do that. It's important that you don't own that. It's important that you come back to, look, I'm just here to help you. I'm here to coach you to success, and etc. Because if you take on kind of what they project at you, they've successfully changed the topic, and now you're arguing about that rather than the math.